In the previous lesson, we made a Nand gate. I want to make that same Nand gate again, but this time with a little bit of a change. The C output was really the output from an AND gate, and the D output was the output from a NAND gate. I want to be able to see both outputs. I want to be able to see both outputs. Alright, how are we going to do that? Well, let's see. There could be a way. First off, let's go get our two input devices, the switches. 1 and 2. And what else do we need? We need an AND gate. Draw, control device, an AND gate. What else do we need? Let's stop for a second and do some thinking now. I'm going to put the switch there and there. The AND gate will go here. I'm going to connect them up. Output to input and output to input. Now, I also want a, where'd it go? Oh, there it is. Invert gate. I'm going to put that here. That didn't go where I wanted it to go. I'll move it. And I want an LED here and here. I also want, well, let's hook these up for a second. Draw the wire between these two guys. Then I'm going to put this guy here and this guy here. That's very strange. I'm going to go get two unique devices that we've spoken about already. One is an output device called a signal sender. I'm going to click right here and I'm going to configure this immediately. This guy's name is going to be let's call it 111. That's as good a name as any. And I'm going to put Mr. 111 right there, out of the way. I'm going to draw a wire from the output of the AND gate to the input of the signal sender. Hopefully it'll take. There we go. Now, I'm now going to draw an input device called a signal receiver. Put that there. I'm going to configure it immediately. I'm going to call this. I'm going to tell it what signal sender to receive data from. 111. So now these two are logically connected. This guy and this guy are connected. What gets sent here will get sent to here. Now, what do I now want to do? Now, I want to take a look at this. I've got an AND gate here. Its output is here. I'm connecting this output over to here. So here's the output from the AND gate. I want to immediately send that output from the AND gate to an LED device so I can see if it's working or not. And I also want to send the same signal to the NOT gate to invert it, and then it will get sent to its own LED. this look a little bit neater. Okay. There we go. That's pretty neat, I think. So, let's put some labels on here now. Let's draw and text, and I'll put A here, B here, C here, C here, and D here. Alright, let's make that look nice and neat. So first guy will be A. This guy will be B. And let's move A a little bit closer, like that. This guy is C. He's the output of the AND gate. C. Now, I could move this closer like this. Yes. Okay. That's too close. Alright, now there we go. Now, this C output, I think I should send it here. Otherwise it could look confusing. How about if I put it there? That's pretty good. Or if I put it there. That's even better. So I've got A, B, and C. Down here I've got A, B, and C. This C is the output of the AND gate. So I wrote the word AND right over there. C and the output of the AND gate are one and the same. Now that output of the AND gate gets sent to the signal receiver, which sends the AND output to two places. Now I'm going to label this as C because it is still the AND output. It's been sent someplace else, that's all. It's being sent to this LED. It is also the very same guy is being sent here to this NOT gate. It gets inverted by the NOT gate and becomes output D. And that's what you see here. These 1, 2, and 3 are the same signal. They're the same AND gate output going into two separate devices, the LED here and the NOT gate here, which will invert it and turn it into output D, which will affect that LED. Wow, that is amazing. And we'll take note of what's going on down here what's going on up here, down here in our truth table. Ready? Here we go. Let's turn the simulator on. Let's run it. Alright. Now, A is 0. A is 0. And right here, A is 0. And B is 0. B is 0 over here. The output goes to the AND gate and gets turned into a 1. The 1 is sent here to 111, received here to the signal receiver, labeled 111. 0, 0, 0, output is a 0. 0 gets sent to 111, received by the 111 receiver, and sent to the LED, which is off. So the AND gate, that's a 0. And you can see its LED is off. This AND gate's LED is off. The same AND gate output is sent to the NOT gate. Inverted becomes a 1, and the light goes on. The light is on. Alright, now we come over here to the switches again. Now A will be on. A is going to be on. And B is going to be off. So A, let's turn that on. B is off. What do we get? We get a 1 and a 0. That's going to give me a 0 on the AND gate. It's sent over here. The 0 is sent to the light, and that's a 0, clearly. The 0 is also sent to the NOT gate, and it becomes a 1, which turns the light on, and the LED goes on. Beautiful. It's working well. Notice C and D are opposites of each other. The output of the AND gate and the output of the NAND gate are opposites of each other. Wow. Alright, well, let's see if that ever changes. Now, I'm going to shut both of them off. Now I'm going to have what? A has to be off, and B has to be on. Alright, so A is off, B is on. Let's see. That'll a 0 and a 1 will, ANDed together, will become a 0. That's sent over here. 0 is sent to the light, and oops, that's off. So that's a 0. Its LED is off, but it's sent over here. The same 0 is sent here to the inverter, which changes it to a 1, which turns the D output to a 1. LED goes on. D output is 1. LED goes on. Now, the next one, A and B are both on. So let me turn A on and B on. What do we get? 1 and a 1. Output is going to be a 1 for an AND gate. Gets sent to 111 sender, and the 111 receiver gets it and sends it to the AND gate. AND gate's LED, and we get a 1. It gets turned on. But that same 1 gets sent to the inverter, and the inverter turns it to a 0, and the LED goes off. So D becomes a 0, and the LED goes off. Wow, that's amazing. Truly amazing. So let's check this again. Both of them are off. C is 0. D is 1. Let's go to the next one. A is 1, B is 0. A is 1, B is 0. C is 0, D is 1. C is 0, it's off. D is 1, it's on. Perfect. Let's go to the next one. A is 0, B is 1. A is 0, B is 1. And what do we get? C has to be off, D has to be on. C has to be 0, D has to be 1. And you can see C is 0, D is 1. Finally, A and B are both on, or 1s. 1 and a 1. And that means C down here is a 1, D is a 0. And you can see C is a 1, and D is a 0. It works. Oh my goodness, it works. That is incredible. Well, that's it for now. So long from Gary D777, aka Hoboken Gear. Bye-bye now.